Hello, and welcome to this tutorial about modal analysis. In this tutorial, you will learn how to constrain a model using RBEs. Then you will set up and run a solution for normal mode analysis, and finally review the results of that analysis. First, we need to retrieve the meshed model that we will use for this tutorial. Let's head to the location where the file was saved and drag and drop it into SimLab. Next, we will create RBEs for the bolt holes. Let's select the negative X face of the body as you see here. Please be sure to change the selector to face selection. Then we will open the right mouse button menu and apply Select Adjacent 2 times. Open the right mouse button menu again and choose Select Features to search for cylinders. We search for full cylinders with a radius between 4 and 5. Next, let's head to the Analysis ribbon, Connectors, Create RBE. With the full cylinder faces already selected, we can choose the RBE2 option. In addition, we choose to create separate RBE for each grouping. Click OK. We can see the RBEs are created. It is now time to define the solution. Let's head to the Solution ribbon and choose Structural Dynamic Stress. Please be sure that OptiStruct is the solver. Then you can choose Solution Type as Normal Mode. Finally, you can select all the bodies using Ctrl-A and then confirm with OK. We can see that the solution is created in the Solution browser, and the Analysis ribbon changes to the loads and constraints related to normal mode analysis. Now we will set up the constraints. In the Analysis menu, select Fix Constraint. Change the selection filter to RBE node to select all of them. This selection filter makes it possible to select only RBE node centers. Check the X, Y, and Z displacements, then confirm to constrain the RBEs in the X, Y, and Z displacement directions. We can see that the node constraints are created. Next, we will change some solver settings. Let's right-click on Settings and choose Solver Settings. We will set the values as shown with a minimum frequency of 500 and a maximum frequency of 5000. Since we didn't perform a quality cleanup on our mesh, we can choose Check L equals No to ensure that the element quality won't interrupt the analysis. We're now ready to run the solution. Let's right-click on Results in the Solution browser and choose Update to run the normal mode analysis. Note that we did not define properties for our model, so we can let the solver assign a default here with no issues. You can see that the analysis is running with the yellow circle next to the results. You will know the analysis is complete when the circle turns green. The results. In the Results panel, we can change the display mode by clicking on different modes. Mode 10 was displayed by default, and now we can see Mode 1 and Mode 3, and so on. We can also change from the resultant component to the X, Y, or Z component, and back again to resultant. We can also animate the modes. Let's change to Modal Animation Mode and click on the play button to view the animation. At this point, we can save the solved model by selecting Save from the File menu, or going to File, Save, or Save As. We could also export the results in the desired format by using File, Export Results. This completes the tutorial. Thank you for viewing.